Hello and welcome to my channel. In this series, I take you through past VCAA Maths Methods exam questions and provide you with full work solutions. In today's video, we're going through question 11 and question 12, the multiple choice questions of the 2020 exam to VCAA exam. So as always, I'll invite you guys to attempt both of these questions first before watching the solutions. And then we'll get stuck right into it, I guess. So question 11 reads, the lengths of plastic pipes that are cut by a particular machine are a normally distributed random variable x with a mean of 250 millimeters. Z is the standard normal random variable. If the probability of x is less than 259, and that's equal to 1 minus the probability z is greater than 1.5, then the standard deviation of the lengths of plastic pipes in millimeters is. Great, so going to underline, we know for this random variable x has a mean of 250 millimeters, and what we're actually looking for is the standard deviation of x, right? So think of that as mean of x and the standard deviation of x. We know we've got this z being the standard normal random variable, so the mean of z, hopefully you guys are familiar with the standard normal, has a mean of 0 and a standard deviation of 1. Great, so I find these sorts of questions, it usually helps a lot to just draw out some normal distributions and then place in values to sort of indicate the regions that we're looking for. So on the left hand side is this random variable x. We know it's got a mean of 250, but the region that we're looking for is less than 259. So 259, and let's just shade all that region in there. We know that's going to be equivalent to 1 minus the probability that z is greater than 1.5. So if we draw another distribution, and this is the z distribution, so we know it's got a mean of 0, standard deviation 1, and if z is greater than 1.5, so we need to draw 1.5 in. So if we were to isolate, ignore that 1 minus, and probability z is greater than 1.5, we would be shading in this region here. However, since it's 1 minus that, we're just going to shade everything on the left-hand side. So you can see now that the 259 millimeters for a mean of 250 is equivalent to having 1.5 on the standard normal distribution, which has a mean of 0. So from here, it's just a matter of using that simple formula to convert between z-scores and actual values. So we know z is equal to x minus the mean over the standard deviation. And plugging in our values, we know that z is 1.5, would be equivalent to that 259 millimeters minus the mean of 250 over the standard deviation, and this is of x. Rearranging that, you'll get standard deviation of x is equal to 9 over 1.5, which would be 6 millimeters, which gives us option C there. Great, so not too bad. It's very common to use these symmetry properties in questions like this, and that's sort of what the left-hand side of that expression is relying on, the complement region, 1 minus that region. You can see once you've got it drawn out, it should be hopefully pretty straightforward from there. So moving on to question 12. A clock has a minute hand that is 10 centimeters long and a clock face with a radius of 15 centimeters as shown below. So we've got this diagram. It says tip of the minute hand to the base of the clock face is h centimeters, and we know the midpoint's 15 centimeters. Great, let's keep reading. At 12 o'clock noon, both hands of the clock point vertically upwards, and the tip of the minute hand is at its maximum distance above the base of the clock face. The height h centimeters of the tip of the minute hand above the base of the clock face t minutes after 12 noon is given by. Great, so what they've got annotated here in this diagram, h is what we're looking for. We're looking for a function that models the height above the base of the clock. Quite a wordy question. Don't be afraid to read it 2 to 5 times, however many times it takes for the information to sink in. It's probably worthwhile, underlining keywords as well. So we know the minute hand is 10 centimeters. Clock has a radius 15. I find sort of looking at this diagrams more useful than probably reading the text, to be honest. And we know it's all in terms of time after 12 noon. Great, so we know that the minute hand goes around the clock every 60 minutes, right? So the period of this function should be 60 if this is in terms of t minutes. So it is in terms of t minutes, so therefore we would expect it to take 60 minutes to go around. So hopefully we remember the formula for the period of a sine function. The period of a sine function is equal to 2 pi on n, and that's going to be equal to 60. So if we were to rearrange that, n should be equal to 2 pi on 60, or just pi on 30. So therefore, within the sine term, or the cosine term, they both would have the same period. So we'd have pi on 30 t. So which of these have that? So this one does, this one does, this one doesn't, this one doesn't. So straight away we can rule out C and D. From here, we'll need to confirm which of these values, which of these functions would be correct. Now the approach that I took to answer this part was subbing in for a particular time. In this case, subbing in for t is equal to 0. So at time t is equal to 0, we know we should have a height of the base of the clock to the center, so that's sort of the radius there, plus the length of the minute hand. So it's going to be 15 plus 10. So we should expect, or we know that the height h of t will be equal to 25. Now if we go through these functions to confirm which of these would be correct, we know that a sine function on the unit circle, when t is equal to 0, puts the angle here. So that's a horizontal component. So the sine of a horizontal component is 0. So therefore this here would be 0, which means the height is just 15. So it can't be A. B is in the same boat because the sine term, when t is equal to 0, goes to 0. And again, we've got the height of 15, so that's not right. What about cosine? So cosine of the angle 0 would provide us with a value of 1. So this whole cosine term goes to 1. 1 times 10 is 10, plus 15 is 25. So it's got to be E. There's the answer there. So the math itself isn't very difficult for this question, but it's in terms of comprehension of the question and understanding how to sub in the correct values to solve for your unknowns there. Great, so let's look at the examiner's report. I'll jump back to question 11. So question 11 was answered reasonably well with 60% answering correctly. No comments on the examiner's report there. Question 12 wasn't answered quite so well, with 45% getting the correct answer E. And you can see in the comments there, they sort of, I think, use the same approach, but perhaps in a different order. They say the maximum height is 25 centimeters at t is equal to 0, like we had recognized here. Hence options D or E. So they actually do that step first to rule out all these sine functions. So they rule A, B, C, and then they're just between D and E. Then they work out the period as well, like we did. But you can see it's the same steps there. Great, if you found this video useful, then please give it a thumbs up, share it with friends or classmates. If you're new to the channel, then please subscribe for more content like this in the future. Try to put out a video at least once a week. Lastly, I do take video requests, so if you have any specific questions you'd like to have answered, and I'll work through and upload that to the channel as well, then please shoot me an email at yourmathquestions@gmail.com. Thanks for watching, guys. See you in the next one.